Hello friends, a very good morning to all the students. Am I audible to all? Okay, thank you all for your responses in the chat box. So dear friends, if you remember in the last lecture I had given you one numerical of the diesel cycle as the practice numerical. So this was the numerical which I asked you to calculate by yourself. So kindly give me your answers in the chat box which you have calculated in this numerical. I want the answers from the majority of the students of all the four parameters which were asked to calculate in this numerical. Kindly give me your answers in the chat box so that I can verify your answers and then I will display my answers so that you can cross check with the answers. Okay, some students have replied me in the chat box. Fine. Okay, very good. I am observing your answers. Majority of the students are getting the perfect answers. Very good. Proceed further. What about the other students? Okay, fine. So now I am getting good responses, maximum responses from the students in the chat box. They are responding with their answers and I am observing their values. Okay, fine. Thank you all for your positive response and I have checked all your answers, majority of the students, and I tell all the students are getting the perfect answers. So let me show you mine answer so that you can cross check the answers. So the first parameter which was asked to calculate, that was the compression ratio. So compression ratio, that answer comes out to be 13.96 something. So I have approximated that value to 14. So compression ratio I have taken small r, that is equal to 14. The next answer, that is the cut-off ratio. If you remember, I am using the notation that is RC. So cut-off ratio answer comes out to be 1.686. Then friends, proceeding further, we are asked to calculate the work done per kg of air. So before that, I have calculated the thermal efficiency. So the thermal efficiency of the diesel cycle, eta diesel, comes out to be 61%. And the final answer, that is the work done per kg of air, that is W net, is equal to 427 kilojoule per kg of air. Now friends, the final question, how many students has got all the four answers correct? How many students has got all the four answers correct by calculations? I want your responses in the chat box. Okay, some student has responded me. Very good, nearby answers, that is perfectly fine. You need not to worry as I has already explained you that point. Okay, no issue for that. Very close answers. Fine. Some of the students have responded me in the chat box. Okay, so just calculate the value which you have not calculated. Okay, fine. Thank you all for your positive responses in the chat box. and giving me your comments. So now friends, let us proceed further and start with the new chapter. Dear friends, now we are starting with unit 8, that is the pumps. If you remember, we have completed two important chapters, very lengthy chapters, the properties of gases as well as the heat engines. In both those chapters, there were the derivations, several equations to be remembered, and also we have solved several numericals. Now friends, we are starting with one of the simplest chapter, one of the easiest chapter in the subject of basic mechanical engineering. Pump is a very easy chapter to understand, and if you are asked the questions from this chapter, I suggest you that you attempt all those questions of the pumps and you can get the full marks in this chapter. Only one important point you need to remember: whatever answers you are describing in context of the pumps, you need to draw the good and the labeled figures of the pumps. This is only one of the important prime requirement for scoring the good marks in the pumps. So now friends, let us proceed further in the chapter of the pumps. So these are the main contents which I am going to discuss in the current session. First, we will be understanding some of the basic concepts of the pumps. Then we will understand the applications of the pumps. Proceeding further, we will be understanding the classification of the pumps. And finally, we will understand some of the terminology in context of the pumps. So friends, let us proceed further and understand the basic concepts of the pump. So in general, in simple terms, the pump is a mechanical device which conveys or transfers the liquid from one place to the another place. That means the pump is a mechanical device which is used for transferring the liquids from one place to the another place. The another name of the pump is the hydraulic machine. The pump is known as the hydraulic machine because in the pump, the mechanical energy is converted into the hydraulic energy. Because of this conversion of the mechanical energy into the hydraulic energy, the pumps are known as the hydraulic machines. Remember friends, this is an important point. The pump is always a power absorbing machine. That means for the operation of the pump, we need to provide the power to the pump. And friends, if you remember in the concept of the Rankine cycle, we have used the pump. So in that particular pump, we have done the work on the pump. That means we are supplying the external power to the pump in order to transfer the liquid from one place to the another place. Dear friends, are you remembering that concept of the pump which we have discussed in the Rankine cycle? I want your responses in the chat box. Are you remembering that concept of the pump which we have discussed in the Rankine cycle? Okay, fine. Thank you all for sharing your responses. So now since the pump is the power absorbing machine, the power is supplied to the pump by means of a prime mover. And that prime mover can be considered as an electric motor, The internal combustion engine or the turbine. So either with the help of the electric motor we can operate the pump, or with the help of the IC engines or the turbines the pumps can be operated. The next important definition, that is the pumping. So pumping is the operation in which we are increasing the energy of the liquid so that the liquid can move from one place to the another place. So pumping means the addition of energy to a liquid to move it from one place to the another place. And this pumping operation is done by means of piston, plunger, impeller, propeller, gears, etc. Dear friends, these are the different mechanical components which are used in the pumps for producing the pumping effect. And since this mechanical component or the mechanical system undergoes the pumping operation, this device is known as the pump. So friends, these are some of the basic concepts related to the pumps. Let us proceed further in the topic of the pumps. So here I have shown one of the practical image used in the industries. In the image we are observing that this is a type of the pump which is coupled to the electric motor. So when the power is given to the electric motor, the shaft of the motor will be rotating, and this shaft is coupled to the shaft of the pump. So the pump shaft will be rotated, the pumping action will be taking place, and finally the liquid can be transferred from one place to the another place. This particular line which you are observing in the image, that is the suction line, and this is the delivery line. That means the inlet of the liquid takes place from this pipeline construction, and the outlet, the delivery of the liquid takes place from this side. So this is just for the understanding the concept of the pump. Let us proceed further and understand some more points related to the pumps. Let us understand the advantages of the pumps. In the pumps, there are very less frictional losses, since there are the operation of the mechanical components. The frictional losses will be produced, but when we consider the analysis of the pumps, we have observed that there are very less frictional losses. Also, if we consider the construction of the pump, it is simple. During the operation, almost the pump produces no noise, and there is the minimum wear as compared to the other mechanical systems which is used for transferring the liquids. In addition to the advantages, also there are some disadvantages in context of the pumps. Many times when the pumps are operated in the long run, they produce the cavitation effect. Remember friends, the cavitation is one of the drawback of the pump. And if the pump produces the cavitation, then the effects of cavitation is that will be reducing the efficiency of the pump. Also, since the pumps are continuously in contact with the liquids, there are the problems of corrosion of the several parts of the pumps. And considering the design perspective of the pumps, some of the pumps cannot work at the higher speeds. So these are some of the advantages and disadvantages in context of the pumps. Let us proceed further and now understand some of the applications of the pumps. Dear friends, remember there is the difference between the advantages and the applications. So the application of the pumps includes the pumps are used for pumping the water from the wells, also for the aquarium filtering purposes, for the pond filtering purposes, as well as for the aeration purposes. If we consider the energy industry, the pumps are used for pumping the oil and the natural gas, or from the operating towers to the other components of the heating, ventilation, as well as the air conditioning systems. If we consider the medical industry, then the pumps are used in several biochemical processes in developing and manufacturing the different medicines. If we consider the automobile sector in the car industry, the pumps are used for the water cooling purposes and also for the fuel injection. Dear students, now let me ask you, can you remember some more application of the pumps which you have observed in your practical life? What are the other applications of the pump which you have come across? And if you remember, then I want your responses in the chat box. The places, if you have observed, that were using the pumps for transferring the liquids from one place to the another place. There are several applications of the pumps. I have mentioned only few of them. Okay, so some students are giving me the answers. Okay, the agriculture purposes, the construction sites, very good. In the chemical industry, perfect answer. Also in the firefighting systems, very good. That is one of the good answer. What about the other students? Can you remember some of the applications of the pumps which you have observed? Okay, in the hydraulic lifts can be considered. Very good answer. Diesel power plants, okay, for the power generation. Fine, that is one of the answer. To develop the pressure, okay, for the dirt cleaning. In the thermal power stations, municipal water works, very good. Drainage system, okay, fine. So majority of the students have understood the applications. Let us proceed further and understand some more topics of the pumps. So next point, that is the classification of the pumps. Dear friends, the pump classification is done according to the principle by which the energy is added to the fluid and according to their design features. So considering both these parameters, that is how the energy is added to the fluid, that means how we are performing the pumping operation, and on the basis of the design features, the classification of the pump is done. So in the classification, the first name of the pumps, that is the positive displacement pumps. So these pumps, they operate on the principle that a definite quantity of the liquid is discharged due to the positive or the real displacement of the working element. So friends, in the positive displacement pumps, there will be a positive or real displacement of the working element, and because of this positive displacement, a definite fixed quantity of the liquid will be discharged from the pump. The positive displacement pumps are further subdivided into again two types. They are the reciprocating pumps and the rotary pumps. in the reciprocating forms, by the reciprocating motion of the mechanical element, the pumping action takes place and the liquid is discharged from the pump. Whereas when we consider the rotary pumps, in the rotary pumps there is the rotation of the mechanical element, and because of this rotation the pumping action will be produced, and now the energy of the liquid will be increased and the liquid can easily be transferred from one place to the another. So these are the basic concepts related to the positive displacement pumps. The second classification of the pumps, that is the rotodynamic pumps. So the rotodynamic pumps operate on the principle of the rise in the pressure energy of the liquid by the dynamic action of the liquid. The dynamic action of the liquid is carried out by a revolving wheel which has the curved vanes on it. And friends, as we are proceeding further in this chapter of the pumps, we will be understanding different types of the positive displacement pumps as well as the rotodynamic pumps. So whenever we are discussing that all different types of the pumps, you will be understanding it better, these concepts about the positive displacement pump and the rotodynamic pump. The third classification of the pump, the name is the other pumps. So the other pumps are those type of the pumps which do not belong to the category of the positive displacement pump or the rotodynamic pump. If I want to give the example of the other pump, that is the airlift pump or the jet pump. So these are the two examples of the other pumps. The other pumps, they do not work on the principle of the positive displacement or the rotodynamic pumps. So this is the simplest classification of the pumps. Dear friends, let me ask you, are you understanding these points of the pumps which I am covering in this session? Are you getting all these concepts which I am discussing? Very easy to remember, dear friends. It is one of the interesting chapter and the scoring chapter. Okay, thank you for your responses in the chat box, for giving me the positive answers. So now let us proceed further and understand the different pumps terminology. So the first terminology of the pump, that is head. In the pump, the different forms of energy are expressed in terms of height of the pump. And this height is further known as the head of the pump. That means, friends, remember, if I tell the energy in context of the pump or if I tell the height in context of the pump, both are the same things and both are represented as the head of the pump. So the head in the pumps, the different forms of energy are expressed in terms of height, which is called the head of the pump. So now let us understand some different terminology and the different heads of the pump. The first head, that is the suction head, and in the notations it is denoted as HS. H stands for the head and S stands for the suction. So the suction head is the vertical height of the center line of the pump shaft above the surface of the liquid. So it is considered as the height from the sump level, that is the suction tank, to the center of the pump. So that height is considered as the suction head. Or if I consider in terms of energy, then it is the energy required by the pump to lift the water from the sump level to the pump. That means for lifting the water from the suction tank to the pump, that energy which is required by the pump, that is known as the suction head. So if you understand the definition perfectly, then you are understanding that in the first case, I am considering the definition in terms of vertical height. And in the second case, I am considering the definition in terms of energy. Dear friends, have you understood this point? The concept about the suction head. Have you understood this concept of the suction head, that is HS? Okay, fine. Thank you all for your answers in the chat box. So now it will be very easy for you to understand the next head, that is the delivery head, denoted as HD. So delivery head is the vertical height measured from the center line of the pump shaft to where the leaving of the water is to be delivered. Okay, so that means it is the height or the vertical height from the center line of the pump to the center of the delivery tank. Delivery tank is the location where the water is to be delivered. Or if I consider in terms of energy, then delivery head is the energy required to lift the liquid from the pump to the end of the delivery pipe. That means for transferring the liquid from the pump to the delivery side, delivery tank, the pump will be requiring some percentage of energy, and this energy is considered as the delivery head H. Proceeding further, the next type of the head, that is the static head. Static head, very easy to understand. It is the summation of the suction head and the delivery head. The static head is denoted as HST, that is equal to HS plus HT, the summation of static head and delivery. Let us proceed further and understand the next type of the terminology, that is the velocity head. It is denoted as HV. And friends, if you have observed practically, whenever the water is coming at the outlet of the delivery pipe, the water is coming with the higher pressure. And also there is the movement of the water. So friends, whenever there is the movement of the water, we are considering that the liquid possesses the kinetic energy. So the velocity head is the kinetic energy carried away by the liquid at the end of the delivery pipe. And in order to calculate the velocity head, we are using the equation, that is hv is equal to v square by 2g, where v represents the velocity of the liquid in the pipe. The next and the most important terminology of the pump, that is the manometric head. Remember friends, the manometric head is one of the most important terminology. The manometric head is defined as the total head required to be developed by the pump. That means all the energies which are associated with the pumps, the total of that energies is considered as the manometric head. Or when we consider all the heads which are developed by the pump, the total of all the heads is also considered as the manometric head. So considering the definition of the manometric head, I can write down this equation, that is HM is equal to HS plus HD plus HV. where HS is the suction head, HD is the delivery head, and HV is the velocity head. HFS, that is the frictional losses which are produced in the suction pipe. So that losses also needs to be considered. HFD represents the frictional losses in the delivery pipe. That is also to be considered. And since the pump is the mechanical element, mechanical device, HFP, that is the frictional losses in the pump itself. So we have considered all the losses which are taking place in the pump, and also we have considered the different heads of the pump. So the summation of all these heads, all these losses, that is known as the manometric head. Dear friends, let me know from your side the concept is clear about the manometric head. You have understood perfectly the manometric head. Okay, fine. Thank you all for the answers. Now let us proceed further and understand the next terminology, that is the water power. It is denoted as PW. The power required by the pump to handle the liquid to develop the manometric head. That means a pump wants to develop a particular manometric head, then what is the power required by the pump to handle the liquid in order to develop that particular manometric head. If I want to calculate the water power, then I can use this equation. PW is equal to rho GQ into HM, where rho stands for the density of the liquid, that is in kg per meter cube. G, you are already aware, that is acceleration due to gravity, 9.81 meter per second square. Q, that is the liquid discharged by the pump, flow rate of the pump, that is in meter cube per second. And HM, the important head of the pump, that is the manometric head, and it is considered in meter. The next type of the power in context of the pump, that is the shaft power. Friends, if you remember in the introduction of the pump, I highlighted the point, the pump is a power absorbing machine. So we need to supply the power to the pump, and also the same thing I have explained in the image which I have shown to you. So the shaft power is the power input to the shaft of the pump by the motor. So we can consider in context of the pump, the shaft power is the input parameter and the water power is the output parameter. So if I want to consider the efficiency of the pump, that is eta pump is equal to output upon input. So that I can write down PW by PS. And if we want to convert the efficiency into percentage, so the answer of this equation is multiplied by 100. We are getting the answer of the pump in terms of efficiency, in terms of percentage. So friends, with this I am completing the terminology of the pumps. Have you understood perfectly all the terminologies? Because we will be using this terminology in the discussion of the different pumps. Is it clear to all the students, the terminology of the pumps? Okay, one student is asking what is HFP in the manometric head. Dear student, HFP stands for the frictional losses in the pump itself. Since we are knowing the pump is also a mechanical element, there will be several mechanical components in the pump, that all components will be operated in context with one another. So because of this operation of all those components, again the friction will be developed, the losses will be developed. So we are considering that point of the pump itself. Hence I have written the frictional losses in the pump itself. and that I have denoted as HFP. Is it clear to the student who has asked me this question? Okay, fine. So I am getting the positive responses from your side that majority of the students have understood the terminology perfectly. So friends, with this I am concluding the session from my side. Thank you for watching the current session. See you in the next lecture. Have a nice day. So friends, now if you are having any questions from your side, the session is open to all. If you are having any doubts, you can ask me. Okay, one student has asked me the question related to the numericals. See, for the numericals of the heat engine, you can practice the solved numericals which are given in your textbook. And in the numericals, if you observe, you are given the year at which this numerical was asked in the GTU examination. So if you are confident with all these solved numericals given in your textbook, then you can solve any of the numerical which is asked in your examination. My numericals are very specific. I am not discussing all the types of the numericals, only I am discussing some of the important numericals where the conceptual logic needs to be developed. And if you are understanding my numericals and understanding the numericals given in your textbook, then I expect that you can confidently solve any numerical asked in the examination. I hope I have answered your question. Next student has asked me what is sump level. It is a fixed level in the suction tank from where the pump will be sucking the liquid. Okay, as I am discussing the other different types of the pumps, the concept of the sump level will be much clear. Okay, one student has asked, can we explain the delivery head? Delivery head is very easy to understand. It is the height from the center line of the pump to the center of the delivery tank. So that height is considered as the delivery head. Or if we consider in the other way, the energy required by the pump to transfer the liquid from the pump to the delivery tank, that energy is considered as the delivery head. And to be very simple to understand, it is completely the opposite of the suction head. Is it clear to the student who has asked me this question related to the delivery head? Okay, fine. Any other questions? Any student want to ask me of the topics which I have discussed in the current session? Okay, no need to go for the exercises numericals because there will be some complications in the numericals. Even some data are missing in the exercise numericals. So I suggest that you solve the solved numericals and get the confidence in the numericals. Okay, if you are understanding all the solved numericals, then you will be confident in any of the numericals. Is it clear to the student who has asked me this question? There are no practicals in this chapter, but during my theoretical lectures only, I will be discussing the majority of the practical concepts of the pumps. So thank you all once again. Have a nice day.